Hello everyone, welcome to Ag for Cambridge, the home of Speedset1060. Speedset1060 is our new high-speed sheet-fed single-pass digital printing solution utilising water-based technology for the packaging market. Here we're focusing on folding carton, paper-based and microflute corrugated materials. So why not join me for a deep dive into some of the key features and USPs of the device as we bring it to market. Starting with the feeder, which for our device here is feeding from the right, which is a very early design change for us in order to satisfy the market adoption through switching the orientation from left to right to left. In doing so, we also switch from a portrait to a landscape. We feed on the long edge, and here we are working with industrial offset standard feeder, feeding from the top into our transportation system, which has integrated alignment for pre-sheet registration to ensure each sheet arrives on the transportation system with an acceptable tolerance level. It's important for you to realise here, one of our other USPs here around the transportation system. Transportation system is our own patent that we have a patent granted for, running a steel belt at high speed, 150 metres a minute, up to 500 feet per minute, to allow us to produce sheets up to 11,000 per hour. That is game-changing technology for something of such a device, new into the market. As we come through the print engine, you'll see first of all here the area for the primer. So one of the other key differentials for us for Speedset1060 is it's a full digital solution. Inkjet primer, inkjet inks and inkjet varnish. And as we move through the print engine, the machine is already built with future scalability, upgrades and conversions in mind. We have a primer bar, same print heads, same jetting technology as the inks. We have intermediate drying through infrared to allow for pinning and homogeneity as the fluid lands on the sheet. As we come through the print engine running at full speed, we have the print bars. The print bars here are CMYK, which is the base configuration of the machine. As I mentioned, we have space to add expanded gamma up to 7 colours, orange, violet, green, for example. At this moment, we still have the infrared intermediate drying. So once the drops from the ink land on the fluid of the primer, we need to make sure we have a nice match, a perfectly homogeneous, balanced coverage sheet. As we come towards the end of the print engine with the transportation system, you see here we have the QA, the onboard analytics, the camera system, which is registering the confidence strip data that is printed on every sheet. That gives us great confidence in the reliability, the sustainability of the press, in essence, because running at such high speed with fully covered sheets, it's almost impossible to see any missing nozzles. So in order to do so, to give confidence to our users, our operators, the confidence strip that we print is then linked to the live analytics data that you'll see on the user interface as we get to the back of the machine. As we come past here, you will see we have the space for the varnish, the varnish bars. The 2 varnish bars we have in place for protection. Printing folding carton primarily. The main use case is for protection, but because it's inkjet, we also have the ability to spot varnish. So we can create some nice special effects that enhance the look of the printed packaged product for luxury branding, for example. Once we conclude through the print engine and we've taken into consideration the pinning with the infrared drying, we are into our hot air dryers. This is the expanse and the length of the machine. So with the hot air dryers, again, we are using industry standard offset quality manufactured goods with independently controlled modules. We have 3 independently controlled modules. Our ambition here is to match up perfectly with our specification. Because we're not just looking at folding carton, we're looking at all paper-based materials from paper to microflute. We need to be able to reliably control the drying characteristics. We do not want to sap each sheet with 100% energy and distort the material. So from this perspective, we've selected this drying capability to perfectly match to our design specification and ultimate product intent. As we pass by the dryers, we are into our sample reject area. Our sample reject area is in place to ensure whatever ends up in the final stack is good printed material that can be signed off as part of the job. The sample reject stack works twofold. One is if we have a bad piece of media that it's not printed, so the machine is built with intelligent features, it will detect that and end up in the reject stack. And second part of that is obviously the sign-off, in essence, press sign-off, which is still a key feature in the packaging industry today. Colour matching, print quality, press quality. The idea being that you can perfectly identify those sheets rather than here where we are now, which is at the stacker at the end of the line, where the job will conclude in a perfectly formed, neat, registered, aligned stack. The idea being here that this is not where the process stops. You know, this is an important part of the process, but after printing, inevitably there will be die cutting or some form of digital cutting, folding, gluing, and maybe some foiling embellishment characteristics. I mentioned at the start of this deep dive, we are intended to satisfy pallet to pallet, stack to stack, so we need to ensure the quality. As we come around the machine, you know, we've now swam half of an Olympic-sized pool, just under 25 metres, around 25 metres. We're into the working area. It's a nice, clean environmental environment with a GUI for the operator console, but here you see the user console in terms of the data analytics from the press, the live analytics. This is where the intrinsic data will come from those confidence strips that I mentioned as we were walking the floor, where we see the upper and lower limits of the density to ensure the nozzle performance and nozzle health for reliable printing. Built into the console, it will be no surprise that we have a light box, again for press standards, for colour matching, for colour process control. Independent of that, we have the operator console, the UI, the GUI, the user interface. This is where all the job setup takes place, the file manipulation, the drying settings, etc. This then translates to the press from a control perspective. You've seen the vast size of the machine through this deep dive, so it would be wrong of me to say this is only where you will operate, but you do not have to keep walking around the machine. So this has bi-directional control to another GUI at the feeder end where we started. So if you are working on that area, you have full agility, full flexibility. As we come right at the back of the machine now, we're into the maintenance working area. So we have the operator user area just before us. Now we're into the working maintenance area. And here you see what is becoming fondly known as the ink farm. The ink farm is effectively our ink supply, which are 200 litre, 50-60 gallons of consumables with the primer, the inks and the varnish. This is to ensure we do not have to take the machine down to fill up the machine when the ink is requested on demand. And then behind me here, we have our maintenance area. This explains a little bit the width of the machine. So when we're in maintenance mode, startup, daily startup, service contract obligations, we're not doing that over the press, and we have full accessibility through the middle of the machine. And that, ladies and gentlemen, is the deep dive concluded, and thank you very much for your attention.